today, simulan natin yung yung panibagong topic. Okay, we will start with a new topic, which is the Laplace Transform. Okay, so for some, we have this feeling that the Laplace Transform is actually the very highlight of this course. Okay, lalo na dati. Okay, which mainly because the courses that come after this course, the Advanced Engineering Math course, okay, is dependent on this topic, on this particular topic, the Laplace transform. Okay, lalo na yung feedback control system, because the immediate feedback, the immediate application of the immediate application of Laplace transform is on differential equations and systems that are analyzed in control systems are mainly described or modeled using differential equations. Okay, but since medyo tedious mag-solve ng differential equations every time, the Laplace transform offered a very neat and compact alternative as to how we can solve differential equations. Okay, and in fact, this is the one that we will be focusing on. That is, whatever we discuss, whatever things or stuff we discuss about Laplace transform, the trajectory, okay, is that we will be working towards using your Laplace transform in order to solve differential equations. Okay. That is why you have this kind of diagram here. Okay. So if you may recall dun sa previous course ninyo sa differential equations, you have dedicated your bago pala ako mag-proceed. Were you able to discuss Laplace transform in the previous course? Mukhang hindi. Tama ba? Uy, sumagot kayo.
Hindi po.
Hindi. Okay, sige. Kasi okay. Actually, you could have parang yung last batch na na-handle ko. Kung after kung yung immediate last batch or yung nauna sa kanila, they were actually able to discuss the Laplace transforms in differential equations. Okay, kasi pagkatapos yung mag-discuss ng kung maalala niyo to ha, method of walang tinta yung ballpen ko. Kung maalala niyo yung method of undetermined coefficient, naaral niyo to sa DE?
Opo, sir.
At saka yung variation of parameters. Naaral niyo yung variation of parameters? Hindi na.
Hindi na po.
Okay, sige. So, after you supposedly after you studied the method of undetermined coefficients at saka yung variation of parameters as method of solving, these are methods of of solving higher ordered linear differential equations, whether they are homogeneous or non-homogeneous. Sana naintindihan niyo yung mga letters na sinusulat ko dyan. Again, this is higher ordered linear differential equations. Okay? Either they are homogeneous or non-homogeneous. These are the methods. Method of undetermined coefficient at saka variation of parameters. So there are differences in how they can solve differential equations. Okay? For one thing, ang method of undetermined coefficients concerns with constant coefficients. Kapag yung if your differential equation has constant coefficients, okay, then you can use method of undetermined coefficients. Okay, but if your equation has non-constant coefficients, okay, and under special cases, then it can be solved by variation of parameters. Okay? Now, these are methods of solving these types of equations. Okay? But the thing is that these methods requires multiple steps. Okay, kung maalala nyo kung paano mag-solve ng method of undetermined coefficient, medyo maraming steps to. When I teach this in differential equations, I usually summarize this in 5 or 6 steps. Kung tama yung pagkakaalala ko. I summarize this in 5 to 6 steps. Okay? The Laplace transform would actually offer an alternative to that. Okay? It would offer an alternative to the method of undetermined coefficients and variation of parameters, again, in some very special cases, in order for you to solve differential equations. And the one thing that that is really really striking about Laplace transform is that they actually convert calculus problems into algebraic problems. Okay? Yung mga operations in calculus, like differentiation. Okay? These are the operations in calculus: differentiation, okay, and integration. Okay? Parang ang ayos ng sulat ko ngayon. Are reduced when you use Laplace transforms. These are reduced to some kind of or some form of multiplication. Not exactly, but some form. Okay, some form of multiplication and division, respectively. Okay, parang differentiation gets converted to some form of multiplication, while integration is converted to some form of division. Okay, so that is why when you are working on differential equations in Laplace transform domain, you are actually manipulating these expressions in Laplace transform, okay, using algebra instead of using tools of calculus. Okay, and but one thing that you have to do is to return to the original problem. Then you have to go by performing what we call the inverse Laplace transform. So para mangyayari niyan, ito nga yung process. You have an initial value problem in what we will call later on as the T domain. Okay? T means the independent variable of your function. So parang you start with a DE, okay? A DE in terms of say f of t, a function dependent on t, or a function whose independent variable is t. Okay? You start with that. Okay? And then what you do is you perform Laplace transform methods, or what we say is we get the Laplace transform of this differential equation. Okay, we get the Laplace transform of this differential equation. Now, when we are in Laplace transform domain, which is what we call the S domain. Okay? So again, ang original function natin has an independent variable in t. Okay? When you perform the Laplace transform on that function, okay, that function becomes a function whose independent variable is s. So we shall say that that function is now in the S domain. Okay, is that understood? Sensya na medyo magninibol-nibol lang ako ng konting pagkain kapag tumitigil ako magsalita because hindi pa ako nagla-lunch. Okay, so ayun. So from T domain, from your function having an independent variable in T, okay, we will have a function now whose independent variable is S. Okay. Now, if you are in S domain, everything now is algebraic. Everything can be manipulated by algebra. Okay. So sabi nga what I was stating earlier is that these operations would be converted to some form of will be converted to some form of multiplication and division in S domain. I'm not saying directly ha. Hindi ko sinasabing ang differentiation ay directly multiplication sa S domain and integration is directly division in S domain. No, some form. Okay, mamaya, later on ipapaliwanag natin yung yung tinatawag na yung some form na yun. Okay. And then after which, if you're done, okay, if you're done with with solving, or if you're able to express the function in S domain in some form, okay. So halimbawa na solve niyo na yung say f of s. Okay, you have now remember this is a differential equation in f of t. Okay, so if this gets Laplace transformed, you would need to have you would have an equation, okay, in which the Laplace transform of f of t is some kind of mix in the expression. So you have to isolate f of s from there. Okay. Now if you are able to solve f of s by algebraic means, okay, that is the time now that you have to convert this or perform an operation called the inverse Laplace transform, okay, in order to convert or in order to transform. Okay, the term is transform, not convert. Okay, iba yung convert sa transform. Okay, so the term is transform. In order to transform f of s back to f of t. And then this will now be the solution of your differential equation. So that would be the process of solving differential equations, or more specifically, ordinary differential equations using Laplace transform. Okay, and the process is much more easier if you consider comparing it to the method of undetermined coefficients, which although basically ang MUC, ang method of undetermined coefficients is basically algebra din naman. Although sa bagay, nga pa, hindi siya purely algebraic kasi there are steps in MUC that you have to take derivatives, tama ba? May part yun na may part yun na kailangan yung mag-differentiate. Is that correct? Okay, so hindi siya purely algebraic. The operation is not purely algebraic. Okay? So there. So this is what I know. That is what separates the solution of differential equations using Laplace transform from the tools you have studied in the previous course. Okay? Kasi gagawin nating algebraic problem yung calculus problem. Okay? And when you actually read back on the history of Laplace transform, it's that application of Laplace transform in terms of solving differential equation was not its immediate intended application. Hindi yun yung unang-unang application nung Laplace transform when it was first published. Okay? Laplace is a French mathematician, I think. Parang John Simon, something like that. Nakalimutan ko yung pangalan niya. Okay. When Laplace transform was first published, okay, the immediate application of or the first applications that it was used was for probability theory. Doon siya unang ginamit sa probability theory. Okay? But over the years, siguro mga after ilang years, 50 something like that, an engineer was able to use Laplace transform in solving differential equations. Then that's the time that Laplace transform became a very valuable tool, okay, in engineers mathematical toolkit. So parang naging tool na siya ng mga engineers. Okay? And as time went by, lumawak yung application ng differential ng Laplace transform sa engineering in solving engineering problems. So that is why may impression talaga that when you are an engineer, okay, especially electrical engineer at that, okay, pero hindi lang kasi even mechanical engineers can greatly benefit in this one. Even civil engineers can greatly benefit from this tool. Pero as far as the electrical engineering profession is concerned, napaka-importanting tool ng ng Laplace Transform. Okay? So, ayun. Now, the key motivation for learning about Laplace Transform is the process of solving an ODE is simplified to an algebraic problem and transformations, of course. Okay? This type of mathematics that converts problems of calculus to algebraic problems is known as operational calculus. Because instead of actually getting derivatives and the like, okay, we reduce these operations into somewhat more simplified, approach. Okay. Parang ang idea ng Laplace transform is parang as revolutionary as how logarithms were when it was first discovered. Kung maalala nyo, ang idea behind logarithms is that it reduces multiplication. Okay? It reduces multiplication to addition. And division to subtraction. That was the intended application of logarithms. Especially before or nung panahon na wala pang computers. Because lalo na nung nagkakaroon na tayo ng idea about o nagkakaroon na ng maraming studies about astronomy, okay, in which numbers are getting really large. Lumalaki numbers natin. So in order for our scientists to analyze those kind of problems involving very large numbers, yung computations gets tedious. That is why they have to invent a tool in order for them to simplify their operations. Okay? So ganun ka revolutionary yung idea ng logarithms in terms of noon kasi wala pang computers eh. But now that there are computers, we somewhat still use logarithms, especially when we talk about how computers should compute numbers. Okay. But hindi na yung bayhan, hindi na siya masyadong sa atin. Kung narinig niyo na yung slide rule, okay? Hindi ko naabutan to ha. Nilinawin ko lang, hindi ko naabutan to. Okay. I was not able to use this one. Pero nung panahon ko, inaaral din namin to. I mean, inaaral namin sa theory, sa libro. Okay. Hindi na ako nakakita nito. Okay, hindi na ako nakagamit niyan. Okay. So yun yung ginagamit nilang calculator before. Okay, itong slide rule. Okay. This idea is as revolutionary. Okay, yung idea to na ginamit nila in order to turn math and science around is something that Laplace transform is also being recognized for. Okay? Napaka-importante no na in a sense that it actually Laplace transform was enabled engineers to be able to study systems in a much deeper sense. Okay? So that's how important differential equations in our field. Okay, sa natin. So parang nagiging imperative na ang isang at least ECE, EE, CPE and ME. Itong mga professions na to, at least meron sila somewhat working knowledge of what Laplace transform is. Okay? And although kapag naman ang trabaho nyo is more of an application, hindi nyo naman talaga gagamitin to sa trabaho. Okay? Pero marami kayong perspective na makukuha in terms of systems using Laplace transform. And yun naman yung kailangan natin na baunin when we go to the professional world. Yung mga perspectives, yung mga mindset. Okay? So, ayun. So, ayan, hindi ko na-discuss ng dalawang to. Pero anyway, ayan. Basahin nyo na lang. Okay. So, these are the intended outcomes for this topic. Okay. So, actually yung topic to ninyo, kung papansin niyo, dalawang topics lang siya. Because I would like to really pound on these two topics. Kasi itong dalawang topics ito ang importante sa part na to. Okay. We may be able to not really master yung mga next topic sa topic 3. Okay. But they are important yung topic sa topic 3. Okay. They are still important. As important as these topics ito. Kaya lang, yung mastery kasi yung mastery kasi ng paggamit ng Laplace transform depends on these two topics, itong 2.1 tsaka 2.2. Okay, so that is why hiniwalay ko itong dalawa to be discussed on a week, tapos another week yung yung topic 3. Okay, so that is why we start now in the discussion of the Laplace transform. Okay. May questions ba so far? Ayos lang kayo? Okay, so sige. So again, as I stated before, okay. We start with a function in the t domain. Okay, we have a function whose independent variable is t. So we say that this function now is in a t domain. Okay, the use of t as a variable and not x signifies the fact that later on, that t would actually correspond to time. Okay? Pwede naman natin pinili yung independent variable natin to be x. Okay? But we will be using this, okay, for applications that describe dynamic behavior of systems. When you say dynamic behavior of systems, their output, or what shall we say response, okay, changes over time. So that is why by convention, gagamitin na natin na yung lalagay na natin sa utak natin na yung mga functions na ini-inspect natin, which is for example named as f of t, okay, are actually functions of time. They change over time. Okay, and this t here is basically is time. Okay, pero sa ngayon, since wala pa tayong application, let's just simply call this as the t domain. So this function f of t is in t domain. Okay, now if f of t is a function defined for all positive t, okay, so meaning your function is right-sided. Okay, yung function ninyo is only defined on the right side of the time domain, I mean on t domain graph. Kasi ito yung kung ito yung graph ng f of t ninyo, so ang nasa x-axis is yung t, or yung nasa horizontal axis is yung variable time. Tama? Tama? Pag sinabi nyong ang independent variable ko is t, okay, t should be assigned on the horizontal axis. Okay. Now, we will only consider functions, okay, that have non-zero values, or that have non-zero values on the right side. That is when your t is positive. So kung zero to, yung function natin defined lang sa range na to. And we will consider that we will have this assumption that your f of t, your function, is 0 for negative t. So 0 siya dito sa left side. So that is why we consider our function to be right-sided. Okay? Now, what we will do in order for us to obtain the Laplace transform, okay, obtain the Laplace transform of the function f of t, is that we will multiply this function, okay, with this factor, e raised to negative st. Okay? And then integrate the entire thing, okay, integrate their product, okay, from t equals 0 hanggang t infinity. So we'll be integrating everything out of f of t times e raised to negative st, okay, from 0 up to infinity. Okay? So we will now have this notation. Okay, so this is the definition of your Laplace transform. Okay? Maliwanag? Okay. So yeah. All right, number one. These are the things that you have to remember with this integral. Okay. Number one, this e raised to negative st, okay, is what we call the kernel of transformation. Okay? That's the term we use for this factor. And e raised to negative st is not alone. Okay? In fact, there are many transformation tools that is used in mathematics. Okay? I can name a few. Laplace, Fourier transform, okay? And we also have Z transform. Although, the fundamental difference between these two and this one is that Z transform mainly deals with discrete data. That is, you consider your function to be discrete. Okay? And when you say discrete, it means that your function is not defined for all values of your independent variable. Okay? So, saan natin pag-usapan yun? Because that's the main topic that we will have to study in signal processing. Okay? Pero itong dalawang to, itong Laplace at Fourier transform, these are what we call integral transform. Because basically, they transform, these two transforms a function in one domain, that is in T domain, they transform it into another function in different domain. For example, Laplace transform transforms f of t into f of s. So makikita nyo merong change in independent variable o transformation in independent variable. Okay? While Fourier transform transforms a function like f of t into what we call f of, marami kasing notation sa Fourier transform. Okay? In fact, in our case, since aaralin din natin ng Fourier transform, hindi pa rin ako fix kung ano yung yung notation na gagawin natin. It's either kasi f of omega o kaya f of j omega. Ang dami. Okay, so ayan, actually ito yung dalawang main notations that I am choosing from. I also read in isang book na meron pang tinatawag na parang something like f of ganitong omega. Okay? So, iba-iba kasi yung notation na ginagamit ng iba-ibang libro. Pero in the future kasi when we study Fourier transform in signal processing, ito yung ginagamit yata doon sa libro na ginagamit ko. Okay, but in this book that in advanced math, ito yung ginagamit niya. So, pag-iisipan ko pa kung alin diyan yung tamang notation natin. Okay. Anyway, so ayan. So these are some of the transforms that are used in mathematics. Okay. And so as I say, e raised to negative st is not alone in being of its kind. Okay. There are many. Okay. Yung iba hindi naman natin na concern. So ayun. Pero we call this factor as the kernel of transformation. Okay. Number 2. If you take a good look at this integral, okay? If you take a good look at this integral, this is a number 1, this is a anong tawag niyo sa integral na merong merong limits? Nakalimutan ko.
Definite integral po.
Ayun, definite integral. Ayun, this is a definite integral. Sorry. Okay, this is a definite integral. Nakalimutan ko to. Okay, this is a definite integral. Now, if this is a definite integral, it means that at one point in our evaluation of this integral, we will substitute these limits. Tama ba? Tumatakbo pa rin sa utak ko na na-miss ko yung definite integral. Okay, so magsa-substitute tayo ng limits. Pagkatapos natin mag-integrate, we will have to substitute limits. Right? Okay. But the thing is that the upper limit of our definite integral is an infinite number. Which is basically not a number. The infinity itself is not a number. It's just a concept. So therefore, when we do substitutions, okay? Remember that ang iniisip natin dun sa part that where we have to substitute infinity, okay? We are basically finding the limit of that integral, okay? As the variable t approaches infinity. Okay? Parang, di ba, ang mangyari dyan is that, halimbawa, nagkaroon na kayo ng integral, no? Sabihin natin na your integral is somewhat of a form. Halimbawa na to, ha? Halimbawa, naging integral nyo is something like t. So, halimbawa, integrate nyo to, no? F of t, e raised to negative st dt from 0 to t, 0 to infinity. Halimbawa, ang naging result ng integral operation na to is t. Di ba, you have to evaluate the limits from 0 up to infinity. Tama? Okay. Now, what would happen here is that, ang isipin natin is that we will have to evaluate this as infinity minus 0. Yun yung idea, right? That's the idea. Okay. But again, as I point out, infinity is not a number. So you don't operate it as a number. Okay? Infinity is just a concept. So, when we actually would want to substitute this infinite number here in t, okay, what we actually mean to say is this. What is the limit of, we are actually evaluating what is the limit of t as t approaches infinity. Yun yung method of substituting infinity to whatever function you have here. Okay, so we are evaluating yung limit ng function natin as t approaches infinity. Okay? And in that manner, we call an integral something like this one, na ang upper limit niya is infinite. Okay? We call this as an improper integral. Ito kasi yung gusto kong sabihin sana kanina, parang yung utak ko nasa improper integral. Okay? So, we call this kind of integrals whose upper limit is infinite. Okay, we call them improper integrals. Okay? So, ayun. Pero when we evaluate an improper integral, yung first half nung pag-evaluate natin nung limit is that we are taking the limit of the integral as t approaches infinity. That is, yun yung meaning nun. Okay? Is that understood? Okay. Now take note that you are substituting. Okay, you're evaluating this. Ito yung number 3. Okay. You are replacing t. Okay, you are replacing t with the upper and the lower limit. Okay, and assuming lang na this operation works. Halimbawa, this operation actually works. This would actually become a constant. This becomes a constant. Okay? This limit becomes a constant. If you can recall, pag nag-evaluate ka ng limit of f of t or the limit of say f of t as t approaches a certain number, okay? And this number is a constant. Therefore, this limit is also a constant. Tama ba? Now, why do I have to point that out? Because when you substitute these values, okay, when you substitute this in the process of you are evaluating the improper integral, mapapansin natin that t actually disappears. Kasi nga itong part na to, okay, becomes a constant. The other half, pag sinubstitute na yung constant na to dun sa t, again, t becomes a constant. So therefore, t merely becomes a number after all of this. Ngayon, ano yung variable na may iwan? Yung variable na may iwan na lang dyan is yung s. Remember, e raised to negative st yun. So if you evaluate the integral, at some point, at some part of your resulting expression, there will be an s. But all of the t's would actually disappear because you would substitute t with numbers or with numbers. Okay? So therefore, ang third idea that I would like to impart here is that when you transform f of t, okay, when you transform f of t, okay, toward into f of s, okay, the variables of your new function, or shall we say the variables of your transform, is just simply s. At dapat wala na kayong makikitang when you perform Laplace transform, dapat wala na kayong makikitang t when you are in S domain. Okay? Because the integral guarantees us that t would actually disappear after we successfully perform the operation. Kaya kapag nag-f of s kayo, pag nagla-Laplace transform kayo, at lumalabas sa transform ninyo, merong t, alam nyo na kaagad, mali kayo. Alam nyo na kaagad that there is something wrong with your expression. Because when we are in f of s, our variable is s alone. Kaya nga f of s Because the only independent variable that we have is s. Is that clear? Okay. Now, what is the significance of this s? Okay, what is the significance of this s? S is actually a this is the fourth idea about this. Okay. S is actually a complex number equal to sigma plus j omega. This is omega, ha? Huwag kayong W ng W. This is omega. Okay. So basically, Laplace transform transforms a function in T domain into a complex variable. So basically, f of s is a complex function. Okay, so essentially, we say that f of s is a complex function. Dali lang. Dali lang. Ayan. So basically, f of s is a complex function. Okay? And f of s, being a complex function, that actually lends itself into more applications. Okay? Which include, yun nga, analysis of systems. Kasi that allows us, especially vibrating systems. May mga kino-consider tayo sa engineering na mga tinatawag nating vibrating systems. Okay? Halimbawa, when you build a bridge, okay, when someone builds a bridge, especially if the bridge is kind of long, and yun, your bridge actually experiences some kind of vibration kapag may dumadaan dyan. Actually, kahit wala nga Okay, meron yan tinatawag na natural vibrating phenomenon. Okay, so engineers used to use vibration analysis in order for them to determine paano nakaka-apekto yung mga vibrations na to in terms of yung structural integrity of a bridge, for example. Okay, so that's one application, and that application actually takes advantage of the fact that f of s is a complex function. Okay, but that thing also does not prevent us from applying the Laplace transform in applications that actually involve real numbers. Well, in fact, ma-apply talaga natin sa real numbers. Kaya lang, ang maganda lang kasi sa Laplace transform is that it can show or it can solve problems having multiple dimensions or having 2 dimensions hidden into the mathematical expression that describes a system or that describes a problem. Okay? So that is where we can take advantage of f of s, or f of s being a complex function. Isa pang application ng at maganda ito dahil wala pa kayong circuits too. So I may be the one opening up yung idea ng for example resonance in circuits. Ako mag-o-open ng idea sa inyo tungkol dyan. Okay? Pero were you able to study na ba Kirchhoff's law? Naaral niyo na to sa circuits? Okay. So I'd assume marunong na kayong mag-KVL. Marunong na kayong mag-KCL. Tama ba? Familiar na kayo sa term na mesh? Okay. Sa nodes? Familiar na tayo sa mga terms na yan? Okay, good. Sige. Kasi ang application natin, ang immediate application natin is circuits. Okay, so ayan. So, these are the ideas that we have to remember about this integral. Okay? So, ayan. Now, notations. Let's talk about notations. And this is really important kasi when we write our solutions or when we write these expressions on paper for example quiz or exam or homework, we should be on the same page para nagkakaintindihan tayo. Okay. Again, we start with a function f of t. Okay, pero itong f na to hindi lang naman f lagi yan. Okay? You can also use y. Okay? You can also use another letter for the function name. Just as that we reserve t, the small letter t, okay, for the independent variable of that function. Okay, so you can use any letter here. Okay. Now, here is the thing is that tandaan nyo to in terms of notation. We use lowercase letters for functions in T domain. Okay? Normally, we will use lowercase letters for functions in T domain. For example, f of t, y of t, okay, x of t, and so on. So we use lowercase letters. Okay? Now, we use uppercase letters for functions in S domain. If your function is already in S domain, you would have to use the uppercase letter that describes the function in T domain. So yung Laplace transform ng f of t is basically f of s with f here as an uppercase. Okay? Maliwanag yun? Okay. While ito, yung Laplace transform ng y of t is y in uppercase of s. And yung Laplace transform ng x of t is x. Again, x is in uppercase of s. Okay, so that kapag sinulat natin yung f na lowercase, alam natin that this function, without actually writing the independent variable, or without using the functional notation for this one, then we can say that f is in T domain. And when we write f in uppercase, then we know that that f or that function is in Laplace transform or in S domain. Okay? Maliwanag yun? Okay. Now, we introduce ayun, ito pala, ito. We introduce this this L by hand I write it that way. Okay. Pero sa sa equations, I use backslash script L to write this character. Okay. Pero by hand I use this kind of L. Okay. To denote Laplace transform operation. Okay? It means that if I actually want to take the Laplace transform of f, okay, if I want to take the Laplace transform of f, the proper notation for that is this. Okay? The proper notation for saying or for the proper expression for writing the Laplace transform of f is this one. So ang basa dito is the Laplace transform of f, okay? So this Laplace transform of f or pwede rin namang kasi dito tinanggal ko yung t eh. Pwede rin naman sabihin natin Laplace transform of f of t. Ginamit ko lang ay square brackets dahil may parenthesis ako dito. Okay? But these two expressions are equivalent if we're talking about the same function f. Okay? This is now equal. Ito, yung Laplace transform of f of t is basically equal to f of s. Okay, ulit natin na. We introduce the symbol L, okay, as the Laplace transform operator. Okay? So we shall say that the Laplace transform of f. Sabi ko pa naman kanina, ang ganda ng sulat ko, ngayon nawala na. The Laplace transform of f, which is also equivalent to the Laplace transform of f of t, okay, is equal to f of s. Okay? Is that clear? Ito mga bagay na to yung notation is really important for us kasi we would like to be on the same page when we come into this. Okay? Para kapag gumagawa rin kayo ng report nyo, alam nyo rin kung paano magsulat paano i-interpret ng tama yung mga symbols na sinusulat nyo. Okay? Now, here is another point that I would like to be very clear about. Okay? F of t is not equal to f of s. Okay? Hindi ibig sabihin na nagtatransform tayo from f of t ay f of s. Okay? Shall we say that f of t is equal to f of s? No. They are never equal. Kahit, ewan ko, baka meron nga ilang instances na equal sila, pero they will never be equal kasi unang-una magkaiba sila ng domain. So, kahit sabihin yung 1 equals 1 yan, ibang interpretation ng 1 sa T domain, ibang interpretation ng 1 sa S domain. So, they are completely different. Okay? So, never that you would have to equate f of t with f of s. Okay? Marami kasi sa mga students din that fall into this kind of pitfall when working on Laplace transform. Most especially kapag nagsusulat sila ng solution. Okay. May mga iba na ganito ang ginagawa. Halimbawa, given tayo ng function ng f of t equals t square plus 2t plus 1, for example. Okay. Now, what some students do is this. Kasi mahilig tayo na di ba? Pagka nagsosolve tayo, tapos kung ito uulitin lang naman natin, we actually do not write this every time. Ang ginagawa natin is that we just simply do equal to here. Tama? Tapos, nilalagay nyo na yung expression nyo dyan. Tama ba? Halimbawa ganito. Halimbawa, meron kayong operation, no? Say, meron kayong f of t equals t square plus 2t plus 1. Tapos, i-express nyo lang naman to in another way. Say, for example, gagawin nyo itong t plus 1 square. Tapos, may mga gagawin pa kayo mga susunod. Normally, hindi nyo na nilalagay yung f of t dito. Tama? Ganun ba kayo magsulat ng equations? Okay. But, we will agree on the fact that ang ibig sabihin nito, still, is that itong expression na to, is equal to dito. Okay? We agree to that. Tama ba? Even if hindi nyo nilagay dito, mag-agree tayo na ito equal pa rin dito. Is that correct? Okay. Now, here's the problem with the Laplace transform. Halimbawa, we are looking for the Laplace transform of f of t. Okay? Now, students would just simply write the function and then find the Laplace transform of t squared plus 2t plus 1, which wala pa tayong tula, pero we could write the Laplace transform as 2 over s cubed plus 2 over s square plus 1 over s. Something like that. Okay? And then it will, the student would proceed with some kind of things na gagawin niya dito. Like for example, isi-simplify niya yan. Okay? Having an LCD, so we will have 2 plus 2s plus s square. Something like that. Now, there is something wrong with this kind of writing. May problema sa writing na to. Okay, again, going back here, which assumes na kapag ganito nyo sinulat yung solution ninyo, assumes that this expression is actually equal to this one. Applying that mindset, you would say that this expression is equal to this one. And that's incorrect. Okay? Nakikita nyo kung saan ako papunta sa argument ko? Isa lang yung isa lang yung naka-ano sa akin. Nakaget sa akin. Okay. What I'm pointing out here is that if you're taking the Laplace transform of f of t, you should write it here as a separate equation na. Okay? You may write here, say, you may write there something like the Laplace transform of f, okay, which is equal now to f of s. And then, write this expression. Yan yung mas tama doon. Tapos, pwedeng i-drop nyo na to. Because, basically, ito, equal naman din talaga dito. Okay? Maliwanag ba to? Now, I would like you to kasi to be very sensitive about this writings, okay? These things. They may be small, they may be sabihin nyo insignificant, okay? But in reality, kasi to foundation kasi to. If you're not able to write these things correctly, you will not be able to interpret them correctly also. And these things that most of the time we tend to ignore. Okay? Wala palang volume yung Okay. In most of the times that we tend to ignore these things. Doon tayo nagkakaroon ngayon ng mistakes when we go to some more difficult problems. Kasi kapag mas mahirap na yung mga problem, mas marami na yung nakasulat. Okay? And then hindi tayo consistent with our notation. Nahihirapan tayo mag-interpret ngayon. Okay? And then most especially me, dahil ako mag-evaluate ng papers niyo. So, number one, if your writing is bad, if you write these things, yung solution niyo as bad, the blame is on me. Kasi hindi ko tinuro sa inyo kung ano yung mga tamang notation. Okay? Diniscuss ko na. Okay? Now, kung ito hindi pa rin tama yung pagkakasulat natin, then we share the blame now. Okay? Pareho na tayo ngayon may kasalanan. Nung una ako lang. Kasalanan ko lang 'yon kasi baka hindi ko discuss eh. But I discussed these things with you. So I hope you remember them. I hope you apply them when you make your when you write your solutions, when you write your reports. Okay? So ayun. Maliwanag. Okay. May questions ba so far? May questions ba itong tatlong naka-raise ng hands na to? Si Mr. David. May question ba si Mr. David? Wala na, iniwan na ni Mr. David yung workstation niya. Wala na yata siya dyan. Okay. So, sige, proceed tayo. Now, if we have this as the Laplace transform operator, we also have the operation inverse Laplace transform.
Wala naman po, sir. Nagde-delay lang po sa pag-raise na kasunod.
Okay, sige. Ayun. Sige. So if you have Laplace transform operator as this one, okay. We also have the inverse Laplace operator, okay, written as this one. So this denotes inverse Laplace operation. So inverse Laplace operator. And when you say inverse operator, yeah. When you say inverse Laplace transform, it means you are given f of s, and then you have to transform this back to a function in t domain. Yun yung tinatawag na inverse Laplace operation. Okay? And so that means if we say that we would like to take the inverse Laplace transform of the function f. Again, f should be in uppercase because you only get the inverse Laplace operation of the function in S domain. So therefore, this should be an uppercase. Okay? So if we are taking the inverse Laplace operation of f, o kaya pwede rin naman itong inverse Laplace operation of inverse Laplace transform of f of s. Okay? The answer to this is f of t. Yan. So these are the notations that we have to remember when we study Laplace transforms. Okay? May questions? Wala. Okay. So ganito. Let us use the integral, okay, to find the Laplace transform of a function. This time, what we're given is the Laplace transform of, or the function that we have is a constant function. Okay? So let's find the Laplace transform of f of t equals 1. Again, this is a constant function, or basically constant unity function. unity function. Okay? Sadali lang ah. Okay. Your function looks something like this. Kita niyo yung ano ko? Yung screen ko? Nakikita niyo yung screen ko? Okay. Your function looks, your constant unity function looks something like this. So kung makikita niyo, again, ang assumption natin for all f of t's that we will have to consider here is that zero siya for negative values of t. Okay, screenshot nga natin to. So let us paste it down here. Litan natin ng konti. Ang laki na. Okay. So your constant unity function, okay, is basically defined as 1 for t greater than or equal to 0 and 0 siya for t less than 0. Okay, but again, our assumption is that all of your functions that we will consider in this particular topic, is 0, okay, for negative values of t. This is your t, this is where you locate your t, and this is your function. Okay, or this is f. Yung vertical axis is f, the value of your function. Okay? So since f is 1 for positive t, then you can say ito yung 1 ninyo. So therefore this will be your function. But as you can see, pagdating dito sa negative values of t, where your t is less than 0, okay, the function actually is not defined. Okay, in this case, it is not defined, pero basically we consider this to be 0. Okay? Is that clear? Okay, so f of t equals 1. Again, yun ang ano natin. And by the way, consistent naman siya dun sa definition ng integral ng Laplace Transform. If you recall, that f of s equals the integral of f of t e raised to negative st dt from 0 to infinity. Nakita niyo naman na yung lower limit is 0. So that means actually sa ibang books, this is 0 negative. Okay, it means you actually start at the left of 0. So the integral should actually include 0 itself. Okay, it should include t equals 0 itself. Okay, pero sufficient naman na nasabihin na natin na simply that is 0. Okay, so ayun. Now, since 0 nga ito, since the lower limit is 0, we won't be bothered by the fact that whether may value kasi ito or wala. Okay, whether your f has a value at negative values of t, the integral would actually ignore that. I-ignore ng integral nyo yung values dito. Basically because the integral has a lower limit of 0. So therefore, the integral won't care what the value of your f of t is when t is negative. Okay? So that is why sufficient na condition naman na that we assume that all of your f of t's are 0 for negative values of t. Okay? So, I hope maliwanag yun. Now, we substitute this, this function, okay, here. So, we end up with f of s equals integral of 1, hindi ko nasusunod yung 1, 1 times e raised to negative st dt from 0 to infinity. Okay, tama ba yan? Okay, tingnan nyo yung ginawa ko ha. Naglagay ako semicolon dito. Tapos siya ako nilagay yung f of s. Now, it means na itong equal na to actually pertains to f of s here. Not this one. Kasi may semicolon naman ako dito eh. Okay, yan yung mga, yung mga techniques na ginagawa ko. If I am writing two equations in one line, sineseparate ko siya using semicolons. Okay, so, yun. Now, how do we integrate this? What's the integral of e raised to negative st? Tandaan nyo ha, ang variable of interest natin dito is t. Therefore, s is a constant. Okay? In this integral, yung pala isa ko nakalimutang sabihin pa dun sa dagdag nyo nga yun as number 5. Okay? Dagdag nyo yun as number 5 ha. In this integral, t is the variable of interest in the integration. Therefore, s is a constant or considered to be constant in this integration. Okay? So in that case, ano yung integral ng e raised to negative st? We start with the integral of e raised to u du, which is
plus 1. U plus 1.
Yun ba? Ano yung integral ng e raised to u?
U du po.
Wala. Paulit nga. Anong integral ng e raised to u? Alam nyo, sabihin nyo yung alam nyo. Kasi pagka mali yung alam nyo, sasabihin ko rin naman. At medyo alarming yun kapag mali yung alam nyo.
U plus
E raised to u times
E
u.
raised to U times
E raised to
U
u
times, teka sara,
E raised to U.
times u po.
times u.
Opo.
Teka lang. Ano ang derivative ng e raised to u?
E raised to u times u.
E
EU.
raised,
E raised to U.
e raised to u
Times u.
times
Du.
derivative
U.
ng u. Chain rule eh. Gagamitin yung chain rule. Tama. So ito, pag i-integrate nyo to, itong side na to, i-integrate nyo rin itong side na to. And remember that differentiation and integration are inverse operations. So if you apply them in succession, they would cancel each other out. So therefore, ano yung integral ng e raised to u? Ito, ano yung integral to? E raised to u lang.
E raised to U.
Is to u plus c. Di ba nga ang exponential function nyo has this very special property that when you differentiate it, it's still the same exponential. And when you integrate ito, when you integrate your exponential, it's the same exponential. Okay? Maliwanag tayo doon. Ito siya ha. E raised to u plus c. Okay, hindi nagbabago yan. Yan ang maganda sa sa e raised to u. Kahit anong gawin mo diyan, yan pa rin yan. Okay? So, ito. Ngayon, in this case, your u is what? In this integral, yung u is your u is
Negative ST, sir.
negative st. So therefore, what is du? Ano yung derivative ngayon nito? Here again, s is considered constant.
Negative S po.
So negative s times derivative nung t.
dt.
Tama? Tama?
Yes, sir.
Okay. So ayan. Ngayon, mapapansin nyo ngayon, dito sa integrand ko, we call this integrand. Integrand. Yan. Doon sa integrand ko, meron akong, ito yung e raised to u ko. Ayan, ayan siya. Ito yung dt ko. Okay? May nawawalang factor. Yung negative s. Okay? So, pwede kong ilagay yung negative s na yan dito para makompleto ko yung definition na e raised to u, du. Okay? Kasi kailangan, kailangan pag paggagamit ako ng mga integration formulas. Okay? Ang objective ninyo is that these formulas should be consistent with what you are given. Okay? So, in this case, dahil nga ginagamit ko itong e raised to u du ko, itong form na to, and I have known that u is negative st. So if I actually evaluate du out of this u, okay, I'll have negative s dt. So if I actually write everything in this, if I actually write this, okay, into this form, lalabas dyan, that's e, again, u is negative st. Tapos meron akong negative s dyan, at saka dt. Okay? So kung papansin niyo originally, ang integral ko is this one. Okay, so what's the difference between this at saka itong original form ko? Ano yung difference nila? Ano yung meron dito na wala dito? Anyone? Ano yung makikita nyo dito na wala dun?
Yung negative S po, sir, sa bago mag-erase to negative ST.
So, wala tong factor na to, di ba? Nawawala tong factor to dito. So, ginagawa natin dyan, kung marerecall nyo yung ginagawa nyo sa integral ninyo, is, nilalagay natin yan. That's negative s e raised to negative st dt. Pero, since wala siya sa original equation, kailangan i-operate din natin ito in such a manner, okay, in such a manner that wala rin siya. Magiging equivalent yung dalawang to. Okay, and for us to do that, we have to multiply this integral by a factor. Okay, so that if I actually multiply that factor, okay, and this integral, okay, this product would actually be equal to the original. Okay? And that factor is actually negative 1 over s. Kasi mabe-verify nyo that if I actually multiply negative 1 over s with this thing, yung negative 1 over s, ika-cancel niya yung negative s. So that becomes 1. So therefore, this expression is basically equivalent to this one. Tama ba? Okay. Now, this expression now, okay, if you take a good look at this one, if you take a good look now at your integrand, I can now write that as 1 over s integral of e raised to u, okay, du. Masusulat ko na to, itong integrand ko na to as e raised to u du. Tama ba? Okay. Now again, what is the integral of e raised to u du?
E raised to u po.
So this, dapat hindi ko sinusunod yung integral. So this becomes e raised to u, but u is negative st. So this is e raised to negative st. From 0 to infinity. Okay? Is that clear? May isa akong question. Ganito ba kayo mag-solve ng integral or ganito kayo tinuruan mag-solve ng integral? Ng integration? Be honest, ha? Sabihin nyo kung hindi kasi gusto ko malaman kung paano. Kasi ganito yan. The thing about teaching these things is that each teacher has their own idiosyncrasies. Okay? May kanya-kanya kaming take on each topic. So I might be doing integration a little different from your teacher. From your previous teacher. Okay? Pero hindi ko sinasabi mali siya. Ang sinasabi ko lang, baka magkaiba lang kami ng approach and baka magkaiba lang kami ng pagkakapaliwanag. Okay? So I would like to know kasi itatry kong maging consistent dun sa teacher niyo kung paano kayo tinuruan. Para hindi rin kayo naliligaw. Kasi bagong learning curve na naman to eh. So, fundamentally ba, pareho kami ng approach na ginagamit ninyo? Or ganito nyo ba natutunan yung pag-i-integrate? So, may nag-raise lang hands. May iba na hindi nag-raise ng hands. Okay. So, pero sabihan niyo lang ako kung ano. Sige, ganito. I'll continue with this one. I think naman, nag-agree naman kayo. So, I'll continue on doing my approach. Pero sabihin niyo lang kapag meron konting inconsistency with how you have learned these things. Okay, and then let's try to resolve it. Okay? Kasi, kayo rin, magkakaroon din kayo ng sarili nyong style eh. When you solve these things, meron kayong sariling style. Okay? Which may be the same or may deviate from what your teacher does it before, how your teacher does it before. Okay? So, kanya-kanyang style yan. The thing is that, una, kailangan nyo maintindihan yung style ko. Okay? Pero, hindi ko naman i-impose yung sarili kong style sa inyo. Ang sinasabi ko lang is that, I would like it to be consistent with you. Okay? So that hindi kayo nalilito. Kasi parang every subject na gagamitin itong operation na to, iba na naman yung approach. So, nakakalito yun. That is where students get lost eh. Okay. So, I'll continue. Now, we evaluate now these limits. Okay? We evaluate now these limits as, again, when you substitute, the number infinity here, okay, as part of the operation, we are actually taking the limit of e, okay, of e raised to negative st, okay, as t approaches infinity. That's the correct operation from out of there. Okay? So we're taking the limit of e raised to negative st as t approaches infinity. Tapos yung lower limit naman, minus, okay, we simply substitute 0 dun sa t. So that becomes e raised to 0. Tama ba? Is that correct? Again, this might be something na medyo hindi kayo familiar. Baka first time nyo ma-encounter itong gantong interpretation ng improper integrals. Okay. Now, what happens here? What's the limit of e raised to negative st as t approaches infinity? Tingnan natin sa graph. Para medyo mas magkaroon kayo ng sense kung anong ano niya. Say, kaya may S pala, no? Huwag na pala. Lalo lang kayo mali dito. Okay, pero ganito na lang yung sense. If you actually take a good look at this function, okay, since the exponent here is negative, okay, as your if you actually consider s to be constant, okay, as you actually approach your t, as your t gets higher and higher, what happens to the function e raised to negative st as t gets higher and higher? Is e raised to negative st increasing or decreasing?
Decreasing po, sir.
Decreasing. Okay. Kasi negative yung exponent eh nung base nyo. Pag meron kayong base na yung exponent niya ay mas nagiging negative. Mas lalong nagiging negative. Yung function nyo bumababa sa value. Okay, tingnan natin yung ito pala, pwede palang tingnan na lang natin sa Pwede niyo tingnan yung value nung nung y equals e raised to negative raised to negative x. Tingnan niyo yung function niyo. Pababa yan. And as you increase your your t, your x, your independent, yung exponent niyo. Ano nangyayari dun sa function niyo? Bumaba until such time that function approaches 0. It will never be 0, but it will approach 0. So therefore, the limit of e raised to negative st as t approaches infinity is 0. Is that clear? Okay. How about e raised to 0? Ano value niya?
1 po.
1. Okay. So simply, this is negative 1 over s times negative 1. Tama ba? That pala, nag-parenthesis na ako. This should be written as a parenthesis. Okay. So this becomes simply negative 1 over s times negative 1. So therefore, f of s is 1 over s. So we shall say that the Laplace transform, okay, of the function which is equal to 1, okay, a constant function, is equal to 1 over s. So we can say it this way, okay, or we can say it this way. This is clear? May questions ba? Other questions? So again, pansinin niyo mabuti. Nung nasa f of s na ako, wala nang t. Dahil ito yung sinasabi ko sa inyo. Magsasubstitute kayo ng t somewhere at some point when you evaluate that limit. Dapat pala, dito pa lang, parenthesis na pala to. Yan. Dapat parenthesis na pala to. Kasi numbers na siya. Yan. Okay. At some point, magsasubstitute kayo ng values dun sa t, which would make t a constant. Pero at this point, s now becomes a variable. After integration, okay, tandaan nyo after integration, s becomes a variable again. constant lang siya when it is inside this integral. Because basically, you're integrating with respect to t. So every other variable that you can see here, every other symbol that you can see there, okay, is a constant. Okay? Pero right after you integrate, okay, right after integration, s becomes a variable. Okay? And and t now becomes a constant kasi dahil sa mga limits na to. So therefore, eventually, pag sinimplify nyo yan, it becomes a function of s alone. Okay. Is that clear?
Sir,
Yes.
paano po siya nag-positive?
This is negative 1 over s. Then 0 minus 1 is negative 1. So negative 1
Okay,
over s times negative 1. Sulat
Okay
natin
po,
para
delay lang po.
sige lang. Dapat nga sinulat ko siya. Kasi ang weird nga naman na mag-multiply ka bigla ng ganyan. Ayan. At tanggalin natin tong isa na to. Ayan. Okay. Okay? May questions pa?
Wala na po, sir.
Okay. Now, ito yung tatandaan nyo ngayon. We may be practicing taking Laplace transforms using integration, using this integral. Pero this would not last long. Okay? The idea is, Laplace transform possesses some properties. Okay? The Laplace transform possesses some properties in which allows us to operate on known Laplace transform pairs. Okay? And then these Laplace transform pairs and saka yung properties ng Laplace transform itself can be used to generate other Laplace transforms or other Laplace transform pairs. So kumbaga, hindi tayo magi-integrate lagi. There will be a point that we will be using a table for this one. Gagamit tayo ng table to generate Laplace transforms for the future of other functions. So basically, ito na yung isang kandidato sa ating Laplace transform pair. Okay? Later on, pag-aaral natin, malalaman natin that Laplace transform are unique. Ibig sabihin, a function in f of t has only one pair, okay, or one Laplace transform as its pair. So 1:1 correspondence yan. Okay? So which means that if we are given f of s, okay, and then we are to transform it back to f of t, we are assured that we will not be looking for another answer because there is only one f of t that corresponds to f of s. We call that the uniqueness theorem or uniqueness theorem for Laplace transform. And that says that Laplace transforms are unique. Okay, so may establish natin ngayon na pwede tayong bumuo ng mga Laplace transform pair. So ito na nga yung isa. Okay? Yung f of t equals 1, okay, is paired with f of s equals 1 over s through the Laplace transform operator. So tawag natin dito Laplace transform pair. Okay? And later on, mag-generate pa tayo ng mga ilan pang Laplace transform pair. Okay, and then later on, gagamitin natin yung mga properties para hindi na tayo integrate. So, at that point, algebra na lang ang pag-uusapan natin. Okay? Is that clear? Ito, kayo na lang mag-try nito. Andiyan naman yung sagot eh. Pero basically, that starts from your f of s being the integral of e raised to at times e raised to negative st. Mukhang masasolve dt from 0 to t. 0 to infinity. Okay, which you can simplify as integral ng e raised to negative s minus a times t. Tama ba? Tama tong expression ko? Okay. Baka tanongin nyo, sir, ba't ka nag-negative dito? Okay, ba't ka nag-negative dito? Pwede namang isulat yan na sana eh. We can write naman it, sir, as e raised to ano? E raised to a minus s times t. Tama? Pwede ko naman isulat na ganito yan eh. Tama ba? Okay. Pero bakit, sir, sinulat niyo siya as negative times s minus a t? Okay. Remember that at one point, mag-evaluate kayo ng limit of e raised to negative s minus a times t, okay, as t approaches infinity. Okay, at one point, mag-evaluate kayo niyan. Okay? Now, what happens here is that, since yung, ito kasing e raised to negative s minus a times t is basically equal to e raised to negative t times s minus a. Tama ba? Ano naman, rearrangement lang to ng factors. Okay? So, e raised to negative t times s minus a. Okay. That essentially makes your exponential have a negative exponent. Okay, that essentially makes your exponential have a negative exponent. So therefore, pag in-evaluate nyo itong limit na to, katulad nung unang example, this limit would actually equal to 0. Dahil nga negative yung exponent niya. So if you're dealing with exponentials, sa Laplace Transform, ang main objective niyo is to make the exponent negative. So that when you evaluate this kind of limits, they can be simply resolved to 0. Maliwanag yan? So, can I trust you na kayo na magtutuloy nito pagkatapos nung ito? From that, try to pick it up. Okay? Kayo na to ha. Pero pag magkakaproblema kayo, sabihan nyo lang ako. Okay. So, let us now proceed. Now, ito yung sabi ko. Must we go on in this fashion and obtain the transform of one function after another directly from this definition? The answer is an astounding no. With an exclamation point. Okay? We can obtain new transforms from known ones by the use of many general properties of the Laplace transform, as I stated earlier. Above all, the Laplace transform is a linear operation. Okay? It mainly because it originated from an integral. Okay, so therefore, dahil pinanganak lang siya ng integral operation, it turns out that the Laplace transform itself is an integral, is a linear operation. Ano bang implication kapag ang operation nyo ay linear? Okay, ito yung implications if you say that an operation is linear. Halimbawa ang integral. Okay, halimbawa meron tayong integral, no? Okay. You have say c times e raised to u du. Ano yung integral nito? Wag pala c, k ang gamitin natin. Let us use k instead of c. K. Ano yung integral nito? Anyone? By the way, K here is a constant, ha? Again, ha, kapag ka meron kayong mga integral na ganito, ayan. Pag meron kayong mga integral na ganito, yung variable other than this thing, excuse me, is a constant, sorry. So therefore, in this case, K is a constant. So ano integral dito?
K e raised to u po.
K times
E raised to u
U
plus T.
C. Okay, very good. So ano nangyari sa K? May naging epekto ba yung integral operation sa K? Parang it also undermined my no? Dahil yung paggamit ko pala ng example na e raised to yun, undermined my my argument. Teka, ibahin natin example. Kx na lang. Kx dx. Integral ng kx dx. Ano to?
K multiply by 1/2 x squared po.
So, k times, shall we say k times x square over 2. Pwede naman ganun, di ba?
Opo, sir.
Okay. Plus
C po.
Okay. Sige, ito na yung totoong argument. What happened to k? May epekto ba yung integral sa kanya?
Nilabas lang po yung K sa integrand po.
Okay, so we know that operation as inilabas. Okay, inilabas sa operation. Okay?
Opo.
Yun. We call this ano? Ang tawag dito? We call this property of linearity as its property in terms of multiplication of constant. Okay? In linear operations, okay? Linear operations tend to not operate on constants multiplied to a function. Ibig sabihin, pag may function ka, okay, and that function is multiplied by a constant, okay, any operations applied into this tends to not apply on the constant multiplied to the function. So, ang term na ginagamit natin dyan as Filipinos and as students of math, inilalabas natin siya. Okay, inilalabas natin yung K and then ino-operate natin yung F. Same thing with Laplace transform. Okay? If you're taking the Laplace transform of a function, okay, that is multiplied by a constant, okay, we tend to make labas the constant and then operate on the function. Okay? So that's one side of linear, that's one aspect of linear operations that we know. Okay. Maliwanag? Okay. Maliwanag yun? Okay. That's one. Okay. Number 2. Second aspect of linear operations. Halimbawa, meron kayong x plus 1 dx. Dx. Kunin natin yung integral nito. What do you do?
X squared over 2 plus dx plus c po.
Okay. Ang ginawa natin is x squared over 2 plus x plus c. Ano essentially yung nangyari? Di ba parang tiningnan mo siya o tinitingnan natin siya as parang ganito. Ito, i-reduce natin sa integral ng x square, x dx plus integral ng dx. Kaya meron ka nito eh. Tama? Kaya meron ka nung x square over 2 kasi kinuha mo siya galing dito. Tama ba?
Opo, sir.
Tapos, meron ka nito dahil ito yung pagkaka-interpret mo sa kanya.
X po.
Okay. Diba? So, essentially, ano ginawa natin? Okay. We students,
Distribute.
okay. Ha? Ano yung term?
Dinistribute po.
Ayun, distribute. And while this may be wrong, okay, this notion of distribution may be wrong, but that is how we understand it. So we'll use it anyway. Okay, so we say that the operation has been distributed. Okay, the operation has been distributed. And that is another aspect of linear operations. When you have a linear operation, okay, operating on sum of two functions, you have two functions, f and g. Then you have a general operation, something like this. Okay. If this operation is linear, then we can reduce this operation into this. The operation applies to f, okay, and the operation also applies to g, and then since the operation here is plus, we add them. Sorry, the operation here is addition, so we add the results of the two. Okay, that is another aspect of linear operations. So linear operations has this property that takes out the constant from the function before you operate on the function. Okay, and this one, which tends to distribute the operations on the sum of functions. So basically, ganun din yung yung Laplace transform. So the Laplace transform, if you get the Laplace transform of two functions, say f plus g, okay, you say that this is the Laplace transform of f plus the Laplace transform of g. Okay? And then you combine these two aspects of linear operation on Laplace transform. Pwede nyo pagsamahin yung idea na yan. So that is, if you have a function as ano ba mga natin? AF, okay, plus BG, where A and B are constants, okay, non-zero constants. And then we want to take the Laplace transform of the sum of this, okay. The Laplace transform of this is A times the Laplace transform of F plus B times the Laplace transform of G. Okay? Is that clear? So this is what we mean, okay, by your Laplace transform being linear, or what shall we say, the linear property of your Laplace transform. Okay? So lahat ng operations na linear tend to have that behavior. Okay, so ganun kaagad yung isipin nyo. Kapag may tinutusan yung bagong operation and the operation is said to be linear, applicable tong gantong idea. Okay? So I hope that is clear. Okay? So ganito. If you actually attempt to find the Laplace transforms of hyperbolic cosine 80 at saka hyperbolic sine 80. Recall lang ha. Hyperbolic cosine 80 equals e raised to 80 plus e raised to negative 80 divided by 2. Okay? Yan yung definition ng hyperbolic cosine 80. Okay. Now, here is what happens. If you actually if you would like to obtain again, a hyperbolic cosine 80 is e raised to 80 plus e raised to negative 80 over 2. Or basically 1/2 e raised to 80 plus 1/2 e raised to negative 80. Okay? Tama ba? Pareho lang yan? Okay. what happens there is this. Kung babalikan ko lang itong ano, dapat sir. Ayan, kung babalikan nyo to, tingnan nyo to. Okay? We say that the Laplace transform of e raised to at, okay, is 1 over s minus a. Again, pag na-solve nyo to, malalaman nyo ito. Okay, ma-derive nyo yan. Okay? And consequently, if you take the Laplace transform of e raised to negative 80, okay, e raised to negative 80, that should be equal to 1 over s plus a. Okay? Magiging plus yan kasi ganito mangyayari dyan. Kung ito ay positive kasi, e raised to 80 yan, makikita nyo dito na yung factor na to is s minus a. Okay? Ito kasing factor na to, lalabas yan as denominator. Katulad nung dito sa s, itong s na to, lalabas na to as denominator dito. Lalabas yan as denominator sa Laplace transform. Okay? So in the same manner, itong s minus a na yan, lalabas yan as a factor sa ano ninyo, as a denominator dun sa factor nung Laplace transform ninyo. Okay, so 1 minus s minus a yan. Okay. Ngayon, kung negative kasi itong a, if this is negative, okay, you can actually factor this as negative of s plus a. Lalabas itong factor na yan. And since ito, lumalabas nga as a denominator, okay, as a denominator dun sa inyong Laplace transform, that should be 1 over s plus a. And again, after this lesson, or after this class, you can actually verify by solving this integral. Solve yung integral na to. Okay, tingnan nyo para magkaroon din kayo ng sense of awareness kung ano nangyari sa mga integrals niyo. Okay, but again, we say that the Laplace transform of e raised to 80, okay, is 1 over s minus a. That's another Laplace transform pair na gagamitin natin. Okay. And another thing, okay, is the Laplace transform of e raised to negative 80 equals 1 over s plus a. Okay, parehong form lang naman yan. Basta, ang alam lang natin is pag positive to, negative to. And pag negative to, positive to. That's it. Okay. Now, going back to this problem. If the Laplace transform, okay, if we take the Laplace transform of hyperbolic cosine 80, okay, which itong hyperbolic cosine 80 nga is basically 1/2 e raised to 80 plus 1/2 e raised to negative 80. Okay, using the linearity property. Okay, if you use the linearity property of your Laplace transform, and since Laplace transform operation is linear, we can rewrite this as the Laplace as 1/2, okay, times the Laplace transform of e raised to 80, okay, plus 1/2 times the Laplace transform of e raised to negative 80. Nasundan? Isa na lang yung nagre-react sa ano ko, sa ginagawa ko. Okay. Now, ito. Again, yung Laplace transform ng e raised to 80 is ito. Nakuha natin ito kanina. Okay, so we can this term can be rewritten as 1/2 times 1 over s minus a. Okay? And then this term can be written as 1/2 times 1 over s plus a. Is that clear? Okay. Now, here's the thing that you have to remember about you have to remember about the Laplace transform, and you have to anticipate. Okay? F of s are generally are generally rational functions. Okay? It means, yung f of s nyo normally is a ratio of a polynomial, okay, in s, okay, in numerator and in denominator. So, may generally marami sa mga Laplace transform functions na may encounter ninyo, okay, is rational. So it means that it is a fraction of two polynomials. Okay? Polynomial yung numerator nyo, polynomial din yung denominator nyo. And that's a general case. Okay? And that is why I would say that whenever you are determining the Laplace transform of a certain function, okay, you have to reduce, okay, okay, the function into this form. Kailangan ma-write natin siya sa ganitong forma. Okay? So in this case, ma-manipulate natin to so that we can satisfy this. Okay? Maging rational function siya. So this becomes, labas ko yung 1/2. Okay? And then, what remains is 1 over s minus a plus 1 over s plus a. Okay? In which, kunin natin yung kanyang least common denominator. Okay? Which you can, you can clearly see that would be s minus a times s plus a. So, ano yung mga nasa numerator? Wala sumasagot sa akin. Hindi, sige, dahil mauubusan na rin tayo ng oras, ako na lang.
S plus
On this
A
side,
plus S minus A, sir.
sige. Ayan, tama yan. Very good. S plus A. This is, on this side, this is S plus A. Okay. On this side, that is S plus A. And then on this side, this becomes S minus A. So if we simplify this thing, okay, this becomes 1/2 this becomes 1/2 times yung A na to tsaka yung A ito magsi-0. And then S plus S becomes 2S. And then itong denominator, okay, this denominator becomes S square plus A square. Is that correct? Sorry, minus pala. Tama. Minus. Minus, no? Tama. Difference of squares. Tama ba? And therefore, this simplifies, okay? So we can say now that the Laplace transform of your hyperbolic cosine 80 is simply S over S square minus A square. Tama? Kasi itong 2 magka-cancel out, mag-ratio yan sa 1. So we can simplify your Laplace transform like this. Okay? Now, I would like you to try out that same line of reasoning para naman sa hyperbolic sign, which results to this one. A over S square minus A square. Okay? And then also try those things sa cosine at saka sa sine naman. But take note that cosine, okay, there is a way that you can use complex form of cosine here. Okay, which can be written as e raised to j omega t, okay, plus e raised to negative j omega t, okay, divided by 2. Okay? So, ayan. I-try nyo yan using linearity. Okay? And then, similarly, you can have sine omega t equals e raised to j omega t minus e raised to negative j omega t over j2. O pwede rin namang I. If I yung nasanayan nyo dun sa past lesson natin. O nga, no? I pala yung ginagamit natin. Okay? So, i-try nyo siya. Try doing this approach. Okay, try doing this approach. Okay, into this. And you may have to notice that most of the parts that of our solution, okay, is actually more on algebra. Ito lang naman yung part na nag-transform tayo from here to here. That's the only part that we have transformed. Pero after we have transformed, this is essentially algebra. Okay? Ganun din yung sa sa calculus nyo. Pagkatapos yung mag-derivative, magsisimplify na lang kayo, and that's algebra. Pagkatapos yung mag-integrate, magsisimplify na lang kayo, and that's algebra. Okay? So, ganun din sa operation natin sa Laplace Transform. So, I hope that you would be able to practice these things. Okay? And then, as a final note, bigyan nyo na lang ako ng mga 2 minutes. As a final note, ito yung if you tabulate all of the things that we were able to derive earlier, okay? These are this would be summarized in table 6.1. 6.1 is what it is called in the book by Crazy. Okay? Kaya we will know this table as table 6.1. If we say table 6.1, we are referring to this table. Okay? So this is the table of Laplace transform pair. So nakuha na natin to. The Laplace transform of 1 is 1 over s. Okay, ito hindi natin na-derive to. The Laplace transform of t raised to n is n factorial over s raised to n plus 1. Which can be applied here at saka dito. If you just set n to be, for example, 2 or set n to 1. Actually, if you set n to 0, you would have this one. So mag-apply din yan doon. Okay, we also have been able to derive this one, or kayo, i-derive nyo pa lang ito mamaya. Okay? And then, I was able to show you this one. Try to work on hyperbolic sine, makukuha nyo to. If you actually work on cosine omega t, you would have this one. Ang mangyari kasi niyan is ito. Kung face-to-face tayo, kakabisaduhin nyo. Okay. Pero since hindi naman tayo face-to-face, may reference naman kayo lagi. Pero ito ang ultimate aim. As we go along, your dependence on this table would be diminished significantly. So, ibig sabihin, you would be using this table by memory. And without actually realizing it, later on, kapag medyo na-master nyo na to, hindi nyo na kailangan yung table na yan. Kasi, by practicing continuously, makikita nyo ngayon na parang nakakabisado siya unti-unti. Okay? So, ayun. I'll probably be continuing this at this point with a recorded lecture. Kasama na rin yung 2.2. Okay, so that hopefully by Tuesday, we will be able to start with topic 3. Okay? May questions ba? Wala? Okay, so overtime tayo 3 minutes.
Wala po, sir.
Okay, overtime tayo 3 minutes. Sorry. We'll dismiss the class now and I'll see you on Tuesday. Okay? Sige. Dismiss na tayo.
Thank you, sir.
Thank
Okay.
you, sir.
Thank you po.
Thank you po, sir.
Paano lang ha, palagot na lang ha. Thank you.